Yes, so we are going to draw this, but using the open structure. So in terms of open structure, we have methane. This is methane reacting with chlorine molecule, chlorine non structured bonding. So what happens? This reaction needs UV light. UV light. So here we need UV light from sunlight. The sunlight will split this one here, so that one chlorine atom will come and substitute one hydrogen. So we have this. So these three hydrogens will remain intact. These one will remain intact, the three, like that. Then one chlorine will come and substitute, replace this hydrogen. So instead we'll have chlorine. And finally, this hydrogen will combine with the remaining chlorine to form hydrogen chloride. So that is what happens. That is what happens. This one is a gas, a gas, a gas, a gas. Now, this one is methane. Methane. This one is chlorine gas, but this one is now called chloromethane. Chloromethane. So from here we can see that during substitution process, two products are formed. Like in this case, we have chloromethane and hydrogen chloride. Then we move to step 2. Now, in step 2, because we have excess of chlorine, so we still have more chlorine. And we have seen that during substitution, the hydrogens are replaced continuously as long as chlorine is still present. So in this case, as long as chlorine is still present, the remaining hydrogens will be substituted. So we are going to step 2. Now in step 2, now, we have that is step 2 now. We have chloromethane, Cl3Cl, plus more chlorine. Now, what will happen is that in the presence of UV light, the substitution process will proceed, such that one chlorine will substitute the second hydrogen. One chlorine will substitute the second hydrogen, so that we will remain with CH2. So instead of having CH3, we'll have CH2. And now we'll have 2 chlorine atoms. Plus hydrogen chloride. In terms of this is a gas, and a gas. In terms of the open structure, our reactant here is chloromethane. So we'll have C, H, Cl, H. Then reacting with chlorine gas. So what do we get? The sunlight or UV light will split, will break the chlorine-chlorine covalent bond, and then one chlorine will come and substitute one hydrogen. Will come and replace one hydrogen. So let us replace this. Let us replace this hydrogen here. So we'll have this Cl, H, 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 Cl, Cl, and then here, this hydrogen will be replaced by one chlorine. So we'll have a chlorine there. Chlorine there. So this hydrogen will come and combine with this chlorine to give us hydrogen chloride. So this one, you can either write this or write that, whichever way, but as long as the structure is correct, you are allowed to use what is easier for you. So now, this one is chloro. This one is chloromethane. Chloromethane. Now, this one has 2 chlorine. Because it has 2 chlorine, we say di. So this one is dichloromethane. 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 So, we are dealing with excess chlorine. Because of excess chlorine, we still have more chlorine. And because we still have more chlorine, then it means that we still have hydrogen atoms to be substituted. So in our step 3, the dichloromethane will undergo further substitution process. The dichloromethane will undergo further substitution process. So let us see what will happen in step 3. Let us see what will happen in the 3rd step. So we are saying in the 3rd step, it is the dichloromethane that will undergo substitution. So step 3. Now, in step 3 we have CH2Cl2. This one is dichloromethane plus chlorine, more chlorine, because we have excess chlorine. Now, the next thing that will happen is that one chlorine atom will substitute one hydrogen here. So we are going to replace one hydrogen with another chlorine. So chlorine will not be 2, but chlorine will now be 3, plus hydrogen chloride. So in this case, we have trichloromethane, because they are 3, tri. In terms of open structure, we have C, we have Cl, H plus Cl. Now, what will happen? What will happen is simple. Let me economize the use of my body. So let me start it here. Cl, C, H, H, Cl. That is 1 carbon, 2 hydrogens, 2 chlorines, plus chlorine. So this one will give us 1 chlorine. We have said 1 chlorine will substitute 1 hydrogen. So let us remove this hydrogen. Replace it with chlorine. So this chlorine will come up here. Meaning now we'll have chlorine, carbon, chlorine, chlorine, carbon, chlorine. Then up here, instead of having hydrogen, we'll replace it with chlorine. This one will remain as hydrogen. So plus this hydrogen from here will combine with this chlorine remaining here to form hydrogen chloride. So this one is dichloromethane. Dichloromethane. And this one is trichloromethane. The last step. So that's what happens. The last step, this trichloromethane will undergo. The trichloromethane will react with more chlorine to form. Now, this chlorine, one will come and remove the remaining hydrogen. So we will remain without hydrogen, but we now have 4 chlorine. So this is trichloromethane. Because you have 3 chlorine atoms, tri. But now this is tetra, 4. Tetrachloromethane. Now tetrachloromethane is a liquid. Tetrachloromethane is a liquid. Now we move in terms of open structure. In terms of open structure, we will have trichloromethane reacting with more chlorine. This chlorine atom will come here and displace. So this one and this, they're the same. Will come here and displace this hydrogen. So that we'll have chlorine, carbon, chlorine. Now where we had hydrogen, the chlorine will come in. We have chlorine plus hydrogen chloride. So this is what is called tetrachloromethane. Tetrachloromethane. So tetrachloromethane. Tetrachloromethane. This is trichloromethane. This is what is called complete substitution, up to where we don't have any hydrogen left. So substitution reactions will continue until all the hydrogen atoms have been substituted. Next time we are going to look at substitution, but by use of limited chlorine. Thank you for listening. Let us meet in the Google class.